Okay, so this is properties of exponents. Okay, most of this should be pretty familiar in this particular section. We will look at a little bit harder stuff as we go through. Exponential expressions. Okay, that just means that it's written with an exponent. Remember, 2 times 2 times 2 times 2 times 2 can be written as 2 to the 5th power. Okay, so the 5 is how many 2's that I'm multiplying together. So this right here is considered our base. Okay, and this is considered the exponent. If you have something with parentheses around it, the entire thing inside the parentheses is part of our base. Okay, and this part is still the exponent. Okay, and it's an exponential expression. It's an expression because we don't have any equal signs. We're just talking about expressions for right now. Okay, so evaluate. 2 to the 3rd power. Notice it says evaluate. That just means do what it asks you to do. So 2 to the 3rd power is 2 times 2 times 2, which would be 8. Okay? Negative 4 squared is negative 4 times negative 4. The negative is in parentheses. Since it is in parentheses, the negative goes with it when we square. So negative 4 times negative 4 is positive 16. Okay, that's different than this one. Okay, here the negative is in the parentheses and the exponent touches parentheses, so the square applies to everything in the parentheses. Here, the exponent just touches the 4, so it only applies to the 4. So it's negative, instead of negative 4 times negative 4, it's negative 4 times 4. Okay, well, negative 4 times 4 is negative 16. Okay, you do need to know the difference between those two. Parentheses with the negative inside means the negative gets squared also. If it's not, then it's going to just be out front. Here, 1/2 to the 4th power means 1/2 times 1/2 times 1/2 times 1/2. You have to know your fraction skills here. 1 times 1 times 1 times 1 is just 1. 2 times 2 is 4 times 2 is 8 times 2 is 16. So the answer there would be 1/16. Okay, that last little bit is just about knowing your order of operations. Remember, exponents comes before multiplication. So here we would have to look at 3 squared. So I'd get 4 times 3 squared, which is 9, and then 4 times 9 is 36. So the answer to that last one there is just 36. Okay, 3 squared is 9, 4 times 9 is 36. Okay, so that's your basic rules. We're going to look at the same thing, but now we're going to throw variables into it. Okay, so x to the n just means x times x times x times x, however many n is. So if it's n to the 5th, I'd have 5 x's. Okay, so suppose we have 5 to the 4th times 5 to the 3rd. Okay, well, if you write that out, that would mean 5 to the 4th means 1, 2, 3, 4 5's multiply together. 5 to the 3rd means 1, 2, 3 5's multiply together. So if I multiply those two things together, well, now I've got 5 times 5 times 5 times 5 times 5 times 5. I can rewrite that as 5 to the 7th. 1, 2, 3, 4, 5, 6, 7. I am multiplying 7 5's together. Well, if you look at the exponents, what just happened to those exponents? 5 to the 4th times 5 to the 3rd, I added exponents, 5 to the 4 plus 3. Okay? So when you're talking about multiplying the same bases, I add my exponents. And the reason why I add the exponents is not because I'm adding instead of multiplying. I'm adding the number of 5's that I'm going to multiply. So I am increasing the number of times that I'm going to multiply 5. Okay? So if I have x squared times x cubed, it's the same sort of thing. X times x. Okay, that was your x squared. And then 1, 2, 3 x's for the x cubed. Well, that makes x to the 5th power. Okay, so the rule here is that if I have a to a power times a to a different power, they can be the same, okay, then I add the powers. Multiplying bases, add the exponents. Multiplying bases, add the exponents. You have to know these exponential rules, okay, so there's your first one. Okay, so a to the 3rd times a to the 2nd. Okay, I'm multiplying bases, so I've got 2 a's there, so I get a to the 5th power. Okay, so if you have two variables and you're multiplying them, add the exponents. Okay, if there's numbers involved, okay, like 6 and 5, well, you still just multiply those. 6 times 5 is just 30. A to the 3 plus 4, which is 7. Okay, same sort of thing happens here. Okay, it's the same base. It's x to an exponent, x to an exponent. So it's x to the, you're going to add those exponents together. 2n plus 1 plus n minus 4. Well, 2n plus 1 plus n minus 4. Just combine your like terms, so I get x to the 3n, and 1 minus 4 is negative 3. Okay, x to the 3n minus 3. So that's the product rule for exponents. So now the quotient rule for exponents, okay, is very similar. Okay, if I have 5 to the 7th over 5 squared, so that on top I would have 1, 2, 3, 4, 5, 6, 7. On bottom I have 1, 2, 5s. Okay, well when we did the very first units, we talked about the product of primes and things like that. Well, when I have a quotient like this, I am allowed to, since it's all multiplication, there's no plus or minus signs in between any of this, it's all multiply, I'm allowed to go through and cancel my like terms on top and bottom. Okay, so when I do that, I end up with 1, 2, 3, 4, 5, 5 to the 5th power. Okay, 5 to the 5th power, which I would then actually multiply out, but it's kind of a big number, so I'm not going to make you write that out. But if it was a test, you would actually do 5 to the 5th power. You'll have your calculator to help you out, so it won't be a big deal. Okay, but look at what happened. What happened to my exponents? Okay, well, I had 7, and I took away 2, so I really am just subtracting. So I could have done 5 to the 7th minus 2, which is 5 to the 5th power. Okay, so the quotient rule here, it's going to do the same thing if I have variables. 1, 2, I write way too hard for mechanical pencils. 1, 2, 3, 4, 5. Okay. On bottom, I would have x squared, so that's 1, 2 of them. Same sort of idea. I would cancel 2 of them out because they match. I would get x to the 3rd power. So I just subtracted exponents. So when you are dividing, okay, the same bases, if these are different bases, if one's an x and one's y, this doesn't work. If one's a 2 and one's a 5, this doesn't work. But if they're both 2's, or they're both x's, or they're both z's, then this works. You just subtract the exponents. Okay? So a to the 3rd over a to the 2nd is a to the 3 minus 2, which is just a to the 1st, or a. Okay, same sort of thing here. Now it gets a little more involved because there's lots of things, but same sort of thing. 12 divided by 2. You still reduce that like the rest of this stuff is in there. 12 divided by 2 is just 6. Okay, 2 becomes a 1, 12 becomes a 6. Okay, here we are going x to the 4th, x squared. Get rid of the smallest exponent, and I say that because later on this is going to change. Subtract it from the largest. Get rid of the smallest, subtract it from the largest. Okay, that's the quotient rule. So I get 6 x to the 2nd power, y to the 5th power, and there's nothing left on bottom, so it's over 1, but we don't need to write over 1. So that would just be my answer there. Okay, one more of those. Okay, be very careful with how you reduce them. 12 and 48 does reduce. 12 goes into 12 once and goes into 48 4 times. Just kidding. 12 goes into 48 4 times. Helps if I can do my own math. Okay, 12 goes into 48 4 times, but that 4 is on bottom. It's 12 over 48. That is 1/4, not 4. Okay, so be very careful there. X to the 3rd, x to the 5th. Get rid of the small one. Subtract that number from the large one. Get rid of the small one. Subtract that number from the large one. So on top, I'm left with x squared, y to the 6th power, and on bottom, I just have that 4. It is also okay if you wrote 1/4 x squared y to the 6th. That would work as well. Okay, but I'm going to do them this way because this is going to be easier later on when we get much more involved fractions. So then, that's your quotient rule. Now we've got the power rule for exponents. A power on a power, we multiply. Okay, because if you think about this, x cubed squared, that means x cubed times x cubed. Okay, well when I'm multiplying bases here, so now I've got 2 x's. Multiply your bases, you add your exponents. 3 plus 3, so I would get x to the 6th. Okay, this is a good time to talk about the difference. Here, I could have just done 3 times 2, which is x to the 6th. If I have a power on a power, so I only have one variable here with an exponent raised to another exponent, I multiply those. Okay, here, I have 2 variables. I've got an x and another x. So when I'm multiplying the bases, that's where you add your exponents. Here I would multiply, here I would add. Okay, now technically these are the same answer because I'm just writing them out differently, but that's the difference between the two rules. So here, t squared to the fifth, t to the 2 times 5. There's only one t. It's raised to the second and then to the fifth, so we multiply. So it would be t to the 10th power. Okay, a to the 6th raised to the x, a to the 6th and then raised to the x. You just multiply your exponents, a to the 6x. Okay, brackets, parentheses, doesn't really matter. We just use brackets because I've already got a set of parentheses on the inside. This means negative 5 to the 3rd raised to the 7. I still have negative 5 inside raised to the 3 times 7, which would be negative 5 to the 21st. Again, if this was a test, you would actually take negative 5 to the 21st and you would do that step. I'm not going to make you write that out here because it's a really, really big number. So we're just going to go with negative 5 to the 21st. If it were on a test, we wouldn't give you a number that big. Okay, but if you did, you would just toss it in your calculator and do it that way. So that is the power rule for exponents. Now the power of a product rule. Okay, so now I'm going to have multiplication inside. This means x times y. Okay, or however many things I have inside. So if I write this out, this would mean xy times xy times xy. Okay, going back to the product rule, okay, if I multiply bases, I add exponents. So x to the first power, x to the first power, x to the first power. So x1 plus 1 plus 1 is 3. So that would be x to the 3rd power. And then I've got y to the first power, y to the first power, y to the first power, y to the 3rd power. So x cubed, y cubed. Okay, x cubed, y cubed. So I could have just taken this exponent and applied it to each one. It is a power on a power. I've got a 1 and a 1 here. So 1 times 3 is 3, and 1 times 3 is 3. So I would get x cubed, y cubed. Okay, so that's the power of a product rule. If I have an exponent outside and a product inside, it just says that that exponent applies to each of those pieces. Okay, so those pieces are called factors. So same thing here. So I've got 3x to the 4th power. So what that means is that I get not 3 times 4. There's a 3 to the 1st power, x to the 1st power. So I get 3 to the 4th power, x to the 4th power. 1 times 4 is 4. 1 times 4 is 4. This is an exponent. So when it distributes, okay, distribute is a good way to think about it, but it's distributing as an exponent. Okay, 3 to the 4th power then is 81x to the 4th. Okay, make sure it goes out as an exponent and not 3 times 4. Okay, it's still an exponent. So xy squared to the 5th. Okay, well that would mean x to the 5th, because it would be 1 times 5, and then y squared to the 5th, power on a power becomes y to the 10th. So you're just multiplying. 1 times 5 is 5, 2 times 5 is 10. Same thing here. Careful with the numbers. The numbers is what trips people up. Make sure that you square it. This would be negative 5 squared, which is positive 25. Okay, x squared squared. So 2 times 2 is 4. 3 times 2 is 6. And 1 times 2 is 2. Okay, you multiply the exponents. Here I have an exponent of 1. 1 times 2 is 2, so I get negative 5 squared. Okay, so that would be your final answer there. So that is the power of a product rule. So now the power of a quotient rule. Okay, so if I have a quotient, which is division, a fraction, raised to some sort of exponent, well that would be p over r times p over r times p over r. Okay, multiply that out. P times p times p is p cubed. Add those exponents. R times r times r is r cubed. Okay, so if you look at it compared to the original, that just means that this exponent applies to both the numerator and the denominator. And that's what the power of a quotient rule looks like. If I have a fraction inside parentheses with an exponent outside, that exponent applies to the numerator and to the denominator. And it will apply to everything in the numerator and denominator. So for instance here, I would get 2 to the 5th over 3 to the 5th, which is 32 over 243, I believe. Okay, 2 to the 5th is 32. 3 to the 5th, I believe, is 243. So that would be my final answer. Okay, so same thing here. A over b to the 6th means a to the 6th over b to the 6th. Nothing else to even do there. That's my final answer. Okay, so same sort of thing on that last one. Okay, you can hit pause if you want to and give it a shot on your own, but it's going to apply the same way. So this is a power on a power, because you got to imagine it applies here. So if I had x cubed squared, okay, so on top I would get x to the 6th, y to the 2nd, because we're going to multiply. We got 1 times 2 there. And then you do the same thing to the bottom. So I've got a squared squared becomes a to the 4th power. There's nothing to simplify, so that's just my answer. Okay, so now the 0 rule, easiest rule. Everything raised to the 0 power is just 1. Okay, Texas, it's all inside these parentheses. It's all raised to the 0 power, which means it equals 1. Okay, this right here, this whole giant thing, all of it is raised to the 0 power, so it's just equal to 1. I do want to add one extra thing to here that seems to trip people up, is if I have something like x squared y 0, okay, what would that equal? Well, the only thing that 0 is touching is the y. It does not touch the x squared. So the x squared, this means x squared times 0, y to the 0 is 1, so it's just x squared times 1, or just x squared. Okay, that's different than if I had x squared y to the 0. Well, now that 0 applies to the parentheses and everything inside it, so this whole thing raised to the 0 is just 1. Okay, so there's a difference between those two, so you got to watch what that 0 is actually touching to see what's going to change into a 1. Okay, so now let's look at simplify all exponent properties. Okay, so we're just going to simplify. We're going to use all the properties that we know and we have. Okay, so starting with, I've got exponents outside. Let's take care of those first. Okay, we're going to follow our order of operations. So inside the parentheses, there's nothing to do. Inside parentheses, nothing to do. So we move to the exponent spot. So this is a power on a power. This is r to the 5th raised to the 3rd. So we get r to the 15th, s to the 6th. On bottom, I've got r to the 15th, s to the 5th. Okay, so now that I'm here, now I can reduce things. 25 and 75. 25 goes into 25 once and into 75 3 times. Okay, r to the 15 and r to the 15th. They just cancel. They're the same. S to the 6th and s to the 5th. Cross out the smallest exponent and subtract that from the largest exponent. Okay, so whenever I write it down, s to the 1st is what I have left in the numerator, and 3 is what I have left in the denominator. So s over 3 would be my answer. Okay, do the same thing for b. Okay, exponents come first, so I get 4x cubed times, okay, 2 to the 5th power, that's 32, x to the 5th, so I took care of the outside exponent first. Now I'm multiplying these two things together, so I get 4 times 32, which is 128, x to the 8th. Multiplying bases, see I've got two variables here, so I'm going to add the exponents. Okay, multiplying bases, I add the exponents. Here I've got just an s power to a power, I multiplied. Here I'm multiplying the x's, so I add the exponents. Okay, 128x to the 8th. So now, this you just have to be careful with your negatives. This one right here, the 3 only applies to the x. So the negative's out front, and I get an x cubed. Here I get negative x to the 3rd power. Well, since this is odd, it's going to remain a negative. Okay? If you need to, do it up here. That would be negative x times negative x times negative x. Well, 2 of them together makes positive x squared. But then I have another negative x, which makes it negative x cubed. So if your exponent, if you have a negative inside, okay, the exponent is odd, it'll be negative. If the exponent is even, it'll be positive. Okay, so 3, 5, 7, 9, those are all going to give me a negative a negative at the end. And if it's even, 2, 4, 6, 8, it's going to become a positive at the end. So then negative x cubed times negative x cubed. Well, the negative times negative makes a positive, and x cubed times x cubed makes x to the 6th power. Okay? So then, x to the m minus 2, x to the m plus 2, x to the first. Don't forget that those, if they don't have an exponent, it's always 1. Those are all the same basis, so I'm just going to add all three of them up. M minus 2 plus m plus 2 plus 1. So I've got m and m makes 2m. Negative 2 and positive 2 cancel, so I just have the plus 1 left. So x raised to the 2m plus 1. Okay, so from there, I got an exponent outside. If I'm going too fast, you can always hit the pause button. You can rewind it and watch it again. Okay, it's after school. I'm trying to get finished here, so you can always hit pause and go back and rewatch this again. So r to the third, s to the fifth. Okay, 2 to the 6th power is 64. Okay, it's an exponent, so 2 times 2 times 2 times 2, 6 times. Okay, r squared to the 6th is r to the 12th. Power raised to a power, we multiply s to the 6th. Okay, so now bases, I'm multiplying bases now. It's an r times an r. So now we get 64 r to the 15th, because when I multiply the bases, so r times r, we add their exponents. 3 plus 12 is 15. S times s, so we add their exponents. 5 plus 6 is 11. One more on this page. Same sort of idea. Got to take care of that exponent outside, so I'm just going to rewrite this part down. 3 squared is 9. Q squared over P squared. Okay, that 2 applies to everything on top and everything on bottom. Multiply that stuff together, I get 9 P cubed Q squared over P squared Q. Does not matter what order I write them in. If I leave it as QP squared, it's going to be the same thing. Okay, get rid of the smallest, subtract it from the larger exponent. There's a 1 here, get rid of the small one, subtract it from the large. So my final answer here would be 9 P to the 3 minus 2 is 1. Q to the 2 minus 1 is 1. Okay, we don't have to write 1 exponents. And that is the end of the exponential rules, and then we moved into the negative exponents, which I'll do on a separate video.